Think about this for a second. How exactly do you recall the exact feeling of your first day of school? Or how do you instantly know the lyrics to a favorite song you haven't heard in years? Over a lifetime, your brain stores trillions of pieces of information. It's an absolutely monumental feat of architecture. Today, we're unpacking the fascinating mechanics of human learning, retention, and memory in this explainer.
So let's dive right in. Where do your memories actually go? A lot of us kind of assume our brains have these tiny little filing cabinets, right? Like little folders labeled birthdays, names, math formulas, or passwords. But here is the incredible part. That's a complete myth. Your brain absolutely doesn't have tiny folders. So where do all those memories live? How does your brain decide what to keep from a classroom lesson and what to just throw away? And why do some memories stay with you forever, while others literally disappear within minutes?
Section 1. Not a hard drive. Debunking the computer myth.
Look at the difference here. It is literally night and day, and it brilliantly illustrates how different our minds are from machines. When you save a file on a computer, it gets stored in one static location forever. But your brain, it works so differently. Instead of dropping a piece of info into a neat little folder, your memories are stored as dynamic, living patterns. They're spread across billions of changing, interconnected brain cells called neurons. For students and teachers alike, realizing the mind isn't just a static Dropbox is a total game changer for how we approach education. You aren't a hard drive, you are a living, adapting network.
Okay, try to wrap your head around this number. 86 billion. The human brain contains around 86 billion neurons, and they definitely aren't working in isolation. Each one of those neurons connects to thousands of others, creating an unimaginably complex communication network. It's like a giant bustling metropolis in there. Instead of just one single road leading to a destination, you've got thousands of intersecting highways connecting different places. Every single time you learn something new, new connections form, and the existing ones just get stronger.
Moving on to Section 2. Creating a new memory. The birth of remembrance.
So let's see how this actually builds in real time. To understand the physical process of how a completely new memory is born, imagine you're meeting someone, let's call her Sarah, for the very first time. To your brain, this isn't just one single event, it's a rapid-fire series of sensory inputs. Step 1, your eyes recognize her face. Step 2, your ears hear her voice. Step 3, your brain notices her smile. Step 4, you physically shake hands. Every single one of these experiences is activating completely different areas of your brain, all at the exact same time.
And then, something truly amazing happens. Those separate pieces of sensory information we just talked about, they get stitched and linked together into one single memory. Scientists call this process encoding, and it is the absolutely crucial first step of memory. Without encoding, nothing can be remembered later. Here's a vital takeaway for any student in a classroom or any teacher delivering a lesson. Attention is everything. The stronger your attention, the stronger the memory becomes, because paying attention literally makes that sensory link tighter. That's exactly why it is so incredibly difficult to remember something you barely paid attention to.
Which brings us to Section 3, the limits of short-term, the brain's holding cell.
Now, not every memory is meant to last forever. I mean, can you remember every single word someone said to you yesterday? Probably not. You might remember the first sentence of this explainer, but the rest goes into short-term memory. And that brings us to this wildly surprising capacity, 4 to 7. Your short-term memory temporarily stores information for just a few seconds or minutes, and most of us can only hold about 4 to 7 pieces of information at a single time. This is exactly why we break phone numbers down into chunks, and it's why great teachers break complex lessons down into smaller, manageable groups. Your brain handles smaller chunks much more easily. But unless you repeat or actively use that info, it's gone.
Section 4. Building long-term connections, rewiring the architecture.
So how do we keep things from just disappearing? Think about a really complex lesson you've completely mastered. To move information from that fragile, short-term holding cell into long-term memory forever, the brain has to physically rewire its architecture. The crucial point here is that learning literally and physically changes your brain. The more you repeat something, the stronger those neural pathways become. Whether it's musicians mastering an instrument, athletes perfecting a swing, doctors running diagnostics, or pilots flying simulations, they all strengthen brain pathways through repetition. When a student studies repetitively, they aren't just reviewing material, they are actively rewiring the physical structure of their mind.
Section 5. The Memory Librarian. Meet your hippocampus.
You know, with all this incredible rewiring happening, there has to be a manager inside your head directing traffic, right? Well, meet your hippocampus. It's this tiny structure deep inside the brain that acts as your very own memory librarian. When new memories are created, the hippocampus helps organize and store them. It basically decides if they are important enough to keep and distribute across the different parts of the brain. And to really understand its vital importance, consider this surprising fact. Damage to the hippocampus can make it completely impossible to create new long-term memories, even if all your older memories remain perfectly intact. Wild, right?
All right, Section 6. Efficient forgetting, why losing information is good.
Now, if memory is so powerful, and we have this amazing librarian up there, why do we forget things? I know it can be a massive frustration for both learners and teachers, but forgetting isn't a flaw. Actually, it's a highly efficient feature. The brain intentionally discards data it deems unimportant to prevent you from being totally overwhelmed with every single license plate or advertisement you see. That's good efficiency. But on the flip side, outside factors can accidentally sabotage our recall. Neural connections fade without use. New memories can interfere with old ones. And crucially for anyone trying to learn or teach, things like stress, poor sleep, and classroom distractions actively make remembering much more difficult. It's a really delicate balance.
Which leads us perfectly into Section 7, Sleep and Efficient Forgetting, the night shift.
As we move into the final phase of the memory life cycle, this quote sums it up so perfectly. Sleep isn't just rest, it's memory maintenance. Your brain's job doesn't end just because you close your eyes. While you're asleep, your brain is actually incredibly busy reviewing many of the things you learned during the day. It tosses out the useless fluff and actively strengthens the important pathways. Your brain is literally organizing today's experiences into tomorrow's knowledge. This is exactly why well-rested students consistently perform better on exams than students who stay awake all night studying. Skipping sleep means skipping the vital maintenance your memory absolutely requires.
So, to summarize this incredible journey, remember that your brain isn't just storing files like a computer. It's building billions of dynamic, living connections. Every single experience you have, every conversation you engage in, and every lesson you learn as a student or teach as an educator changes your brain in small but truly remarkable ways. Your memories help you learn, develop skills, and understand the world. They shape exactly who you are.
I want to leave you with this final thought to ponder. The next time you effortlessly remember the lyrics to your favorite song, or recognize the face of an old friend in a crowded room, will you pause for just a second to appreciate the extraordinary power of your own mind? You are literally witnessing nature's greatest creation at work. Keep learning, keep building those connections, and thank you so much for joining me for this explainer.